So basically, so I'm going to talk about porting Unity games over to Fire devices. And we had it at first as like 5 tips. I have a whole bunch of different tips. And these aren't just for Unity. If you are building just games in general, these are a lot of good best practices that you can use across any platform that you're using to bring over to our devices. So a little bit about my background. So my name is Jesse Freeman. I'm a developer evangelist, similar to Dave at Amazon. And again, our job basically is to help developers like you get on our platform and also connect you with the right people inside the company. That being said, I put my email address up there. I always like to see what people are doing. If you're working on a game, if you need help, if there's something else that you need to get in touch with us about, please feel free to send an email. As Dave also said, we travel a lot. There's a few of us who cover the world. So if I don't respond to you immediately, just bug me again and send me an email. I'm also on Twitter. And I just recently started doing Twitch as well, which I should have put up there. So all the stuff that I've been doing for this game that I'm about to show off, I've actually been starting to leverage Twitch, which is really good for game developers to show just live builds daily of what you're doing. And then my background, just real quick, is I came from agency and enterprise. I did web work for years, working for really large companies. I'm from New York, if you can't tell from my accent. I've worked from everything from Major League Baseball, New York Jets. I also worked at, I did bank software and enterprise, and I always wanted to do games, but being an indie gamer in New York is incredibly difficult. So I wound up cheating a little bit, and I did agency work and corporate work for a long time, and everything I built was actually a game engine. So I built HBO.com, which I think is one of the last Flash websites I wrote that's still alive, and the actual engine that runs it inside is a big game engine. So I've been able to take over the years game architecture and apply it to just the stuff that I love to do. And that being said, I spend a lot of time making games. So this game is a game called Super Paper Monster Smasher. I wrote it a few years ago for Ludum Dare. I can't remember which one. I think the theme was You're the Bad Guy. So I like also making games for my kid. So basically you're this big monster and you go around smashing all the good guys. And I'll get into the game a little bit. But what's really good about this is that I try to build these little examples to show off because there's not too much going in the game. But what it really covers is, how do we get through these 4 parts that are really important to bringing a game over to not just our device, but devices in general and having a cross-platform strategy. So supporting multiple resolution is a big one. Dave was joking about like how having to support all these different resolutions on Android. Fire TV will take care of a lot of that for you, and we'll get into that. But supporting different resolutions, game input, right? How do we deal with going from desktop to mobile to tablets to TV again, right? And optimization, like what can we do to support the widest range of devices possible and optimize our Unity apps. And then also testing on Fire devices. So I'll show you guys towards the end how easy it is just to get something up and running on one of our devices. And all of our stuff that I cover is going to be in our dev portal. So I have the link at the bottom, which is just developer.amazon.com. So for the first time in Amazon's history, we actually have a complete ecosystem now with devices. Everything from a phone to a tablet to a TV. And this is, for developers who are publishing to our platform, it's sort of a new solution that they need to work around is how do you support all these different resolutions and screens and devices. But if you've been building games across all different devices, this is something you've probably been dealing with automatically. One of the advantages that we have, and Dave talked about it, so I'm not going to go too much into detail, is just the reach that we have. So 236 countries and territories and hundreds of millions of customers. And what powers our devices really is our App Store that expands across not only just our devices, such as Fire TV, Fire TV Stick, the HD and the HDX lines, which are our tablets, our Fire Phone, but also the Amazon App Store for Android. So Android users can also download our store and get access to your games. And then also BlackBerry. We're the default App Store now on BlackBerry devices. And the other thing you can do is if you do PC games and Mac games, desktop games, you can actually distribute them through Amazon.com as well. So let's just sort of jump into supporting multiple resolutions and some of the fun stuff that you had to do to kind of get your mind in that set. When I first got started into moving over to mobile, I really had to like rethink how I deal with each of these different screens, right? And at first I started thinking about resolutions. I'm like, well, I'm going to design this game for this certain resolution. But the problem is that you can't design for every single resolution. So what you wind up doing is thinking more about aspect ratios than actual resolutions. And once you think about the aspect ratios, you can actually tell a little bit better the difference between what your game is going to look like and how many extra pixels you'll have by something going from like 8 by 5 to 16 by 9. So in this case, the ones that I kind of keep in mind are 16 by 9, which is going to be TV resolutions and our phone, 8 by 5, which is our tablets, and then 4 by 3, if you're coming from other platforms, this is sort of like the default resolution on iPads. And then the biggest thing is to make sure that your UI and everything supports all of these different resolutions. So that being said, this is sort of a map of the world of our devices. And hopefully this is going to work. Where's my pointer? I love my pointer if I can remember which one is. Nope, that's not my pointer. I hate when that happens. Oh, here it is. It's the big green button. Okay, so our tablet line here are both Fire HDX and the Fire HDs are a 8 by 5 aspect ratio. And you'll see here that what we have is this is just the Retina type of display, right? This is where we've doubled the pixels for the larger tablet, and then we're using the 1280 by 800 resolution. When we start getting into Fire TV, Fire TV Stick, and Fire Phone, we're dealing with a 16 by 9 aspect ratio. So on our Fire TV devices, you'll see that we get full 1080p. And what Dave was talking about earlier is that if you just design for 1080p, let's say the person's TV is a 720p TV, it'll downscale it for you automatically. So you only have to think about one resolution when it goes to Fire TV. And then our Fire Phone is the same aspect ratio. Obviously, it's more oriented towards portrait. But it supports, obviously, portrait and landscape as well. So this is one of the splash screens that are inside of the game. And one of the things that I did was, early on, I wrote a little utility. It's hard to see up here in the top, but there are two lines here. This first line is our tablet's aspect ratio, and this other one is our TV aspect ratios. And so in Unity, I went in and I wrote just a little plugin that will draw an overlay using the gizmos to show me what's my native resolution. So I originally designed this game for web, and it was 800 by 480. And then when I ported it over to Unity, I didn't change anything in the design. I just started thinking about, well, will the game scale correctly to higher aspect ratios? So in this case, as I'm working in the native resolution of the game, I could see guides to say, well, it's going to expand out 20 pixels on either side for 8 by 5, and it's going to expand out 50 pixels on either side for 16 by 9. The other thing is that when you're actually in a game here, you can see I went from the native resolution, and when I actually switch over to a Fire TV resolution, this gray area just gets filled in with the game. So a lot of the times, if you design your game correctly, when you scale out to a higher aspect ratio, what's going to happen is you're going to see just more of the game, right? And this works really good in a game like this where you're running around and you're smashing people, right? You just see more people coming at you. But you also have to take into account that certain games that you do, that may be an unfair advantage if someone's playing on a wider screen device than a lower resolution device. So that's something else just to keep into mind. So the other part, and I'll switch over real quick into Unity, is making sure that you actually maintain pixel perfect cameras. So I do a few tricks around cameras. I'm not going to get totally into a lot of the formulas. They're really easy. I basically, since this is a 2D game, I'm using an orthographic camera. And in this case, what I'll do is I'll take the native resolution. So in this case, it's 800 by 480. And I just take the height and I do the math to say, hey, what should the pixels actually look like at the scale? And I just reset the scale of the orthographic camera. The big trick, though, and you might have seen this in Unity and in certain places, that there's actually sometimes artifacts in 2D games or certain things that the camera isn't at the right resolution, like maybe if it's off by a fraction or it's a floating point. So what I wound up doing is in a game like this, I actually have two surfaces. So right here is my real game, and I'm taking this camera here and I'm rendering this camera out to a texture. And this texture has pixel snapping on it, so that I always get pixel perfect a resolution on that. And then all I do is, if I go to my main camera here, oops, it like zooms in really big. I also use a 1-for-1 ratio, so whenever I bring in artwork in pixel games, I'll do a 1-for-1 Unity unit. But here what you're seeing is that all this camera is doing is just rendering out to what's in this texture. And the other neat trick about this is that I can actually do all kinds of interesting stuff with shaders on this texture that I'm outputting. And instead of having shaders all over the place throughout the game, and I'll talk a little bit about optimizing lighting and that kind of stuff, I actually just run shaders directly on this one outputted texture, and then I save myself draw calls. So this is one of the tricks that I've done to get around having to deal with how do I always make sure that my artwork looks pixel perfect. So let's talk about game input. This is probably the most complicated part of getting a game to run on multiple devices. And it really, it requires you to rethink sort of how you deal with input. So the good news is that if you're already building a touch game, you can easily get it up and running on our tablets because our tablets and our phones support touch right out the gate, right? So there isn't anything you have to do to change that. When it comes to going over to Fire TV, if you're not supporting a controller in your game already, you're going to have to sit down and sort of think about how do you go from touch to controller, or maybe you started off with controller, or if you're in my case, most of the time I'm testing it on a computer, so I still support keyboard, right? So we have to take all these different keys and sort of bring it in. So on Fire TV, what happens is that every box comes with a remote. So if it's a Fire TV, you're going to wind up with this remote, which has the voice search and all of these, all the buttons. And then if you're doing a Fire TV stick, it's the same remote buttons, except it doesn't have the voice search. But handling remote input is way different than something like a controller, right? And we also support in our remote the standard Android key back buttons. So you have back, you have home, and you have menu. So a lot of the times I'll tie those into my game. So if you hit the menu, it pauses the game and stuff like that. We also support an optional controller. So we've been doing some bundles, and these have actually been really successful now on Amazon.com, where we're actually bundling the game controller with Fire TVs. And I think that was a big criticism. And a big thing about what you've sort of heard from this morning about Amazon is that we're very customer driven. So when we hear feedback that people don't like something, we go and we change it. And we're very nimble like that. So in this case, we do have bundles now where we're bundling the game controller. And the game controller is actually so popular that it's actually been out of stock. I think it's out of stock for the next month or so, month and a half. So this is starting to pick up really well on Fire TV. And what's great about this is that if you're building a traditional console game or a desktop game, assuming performance-wise it runs, and I've actually been pretty impressed with what I've seen running on Fire TV, you can also support a standard controller. And so this is the button layout. I mean, a lot of you, I'm pretty sure everyone's seen a controller like this before, right? This is your standard issue sort of like console controller. We have 2 analog sticks, D-pad, 4 face buttons, and then we also have shoulder and trigger buttons, right? And the feedback, I think the best feedback I heard so far was I was at Pocket Gamer, and I was playing Luftrausers with Rami from Vlambeer, and him and I were playing the game for maybe like an hour and a half, and he's like, I have nothing wrong to say about this controller. This is really, he didn't even think about it, and I think it says a lot that, people are very particular about game controllers, especially games that Vlambeer make, to actually, have someone go, especially Rami, to be able to say, that the controller didn't get in the way of his game that needs to have precise control says a lot for our controller. So let's talk a little bit about how do we get a controller and keyboard and all of this thing boiled down into one type of input. So there are a few libraries in the asset store that sort of handle this for you. Whoops. One of the things that oh, my font's really tiny, isn't it? Let's make this old person big. Okay. So is that clear enough for people in the back? I mean, a lot of this I wasn't hoping, it's not, you can't write all this down, right? This is like weeks and weeks of experimenting, but high level it goes like this. I have one set of enumerators, and all I do is I boil down all the input in my game to these enumerators. And in essence, all I need is my game controllers and my objects in my game just need to know what button's being pressed. Is it up? Is it down? Is it left? Is it right? A, B, blah, 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 all the way down. Luckily in this game there's only left and right. But still, I still sort of plan ahead. Coming from this enterprise background, I like to over-architect. So that being said, the whole system in my game actually takes any type of input and sets flags on one game controller class. Here it's our input state. And the input state will keep track of a button has been down, it's been pressed for how long, it's been released at this time. And over time, what happens is that I build different adapters that simply talk to this input state. and the input state lives on my player, for example. Or if you have multiple players, you can have an input state on each player and then multiple adapters that talk to those input states. So to kind of give you an idea of how that works, this input manager here, I'll zoom this in, this input manager just has an array of input axes and touch buttons. So a touch button is just some custom button that I've written using like Unity's new GUI system. So the GUI button will simply have a state that, hey, I'm pressed or I'm not pressed. And then the traditional buttons, I have a specific class down here called input axis state. And I'm using the same input axes that Unity has. So one of the good things like out of the box is that if you're able to get a USB game controller working with your game, the same mappings will work on Fire TV. There aren't any special mappings you need to do unless you're on a Mac and for some weird reason when you plug in an Xbox 360 controller, all the numbers start at 11 instead of input 1. I don't know why. It's just weird Mac drivers. But most of the time, the input just works the same. So what this class does is it goes through, and I'll pull it up in Unity itself, if I could find my monster here. So in my monster, I have my input state that just lives here. And then in my game manager, I have this input manager. And I've mapped horizontal. Its default value is 0. I say if it's more than this value, right? So if it's greater than 0, if it's 1, that means we're moving to the right. And I map it to the right enum. And now what's happening is that this input manager is simply taking all this stuff, abstracting it, and putting it into my state. And then anything else in the game doesn't need to worry about whether it's coming from touch or if it's coming from a keyboard or an input. And so down here you'll see I have touch buttons. And so here I just simply give it a reference to each of the touch buttons that are on the screen. And when this class starts up, it puts all these buttons into an array, and then through the loop, it just simply checks the state and creates a Boolean for whether that button's been pressed or not. And then now the game doesn't care where the input's coming from. It's a very high-level topic. I mean, you could probably do an entire talk just on input alone. But that's sort of the key, right? What you want to do is not have to worry about where input's coming from. Your game just needs to worry about specific inputs, and then you build against those type of inputs. So other things is that you can build a controller-only game for Fire TV. So if you do have a console game and you want to bring it over, you don't have to worry about if it's not playable with the remote. Once you flag it when you submit it to the store that it's a controller-only thing, we handle all the UI that says to the user, first, they can't buy it unless they have a controller. So it'll tell them, hey, in order to buy this game, you need the game controller. And then if you launch it and you don't have the controller, it'll say the controller wasn't detected. Also, we can support up to 7 Bluetooth controllers. So local multiplayer is having a big resurgence now. So that being said, you can do some pretty cool stuff. It is technically 8, but the 8th one is always reserved for the remote. And then one of the important things about when you're submitting to the store, make sure you detect the platform you're on. And by that I mean, and I'll talk a little bit about how I detect platforms, but make sure you show the right controls for the right device. One, it won't pass submission if you have touch controls overlaid on your Fire TV app and you're submitting it because there's no way to touch the screen, right? Although my 5-year-old continues to try to touch the TV screen. So we'll talk a little bit about device detection. So as far as Unity is concerned, we're just an Android device. It comes up as an Android device, and all of our devices sort of return the same thing. The one thing, though, that's unique is if you're looking at Fire TV, it actually comes back as a touchscreen true. So there, you know, I guess Unity can't always go through and check every single platform. So to get around that, what I've actually done is I built a platform detection script. And so what you see outputted here in the console is just like I abstract out my controller input, I also go through and I abstract out what are all the input types that you would have in a particular device. And I have profiles that I can set up for specific devices like Fire TV or Fire TV Stick, where I can actually say, well, no, the profile you're returning, I don't like that profile. This is what your profile should really be. And in this case, it doesn't matter what kind of device comes out the next day, all I do is add a new profile. So my profile just simply boils it down to, are we detecting joysticks? Are we using a keyboard? Is there a mouse? And is it touch? So if I go into this this platform detection class, And I'll show this. Here I have a way that I can register platforms. So automatically, when I request a platform definition, it's going to go through and just iterate and say, hey, these are the available inputs. This is what we think it is. In the case of Fire TV and Fire TV Stick, I'm using their device ID to basically say, well, if you see this, simply return the correct profile. So in this case, I just tell it to return touch as false. And this hung me up the first time I submitted my game because I was just simply looking for touch off. If there wasn't touch, I basically showed the controller text, and it failed submission. So now onto the fun part, optimization. So I'm like really OCD about optimizing from like day one. Usually you're supposed to build it and then optimize it, but I like to build for the lowest platform possible and always make sure that it runs the best on that, because then I don't have to worry about scaling up to bigger devices. So the biggest thing off the bat is always going to be object pooling, right? I mean, this is like game design 101. Unity does a pretty good job around managing draw calls and stuff that are off screen, but I spent a lot of time on how to architect a very simple object pool. And there are tons of tutorials and stuff out there for how to do it. So as you see here, it's just going to continue to spawn all these guys. They keep running, but if you look in the upper right, what's happening is that I have a night object pool, and whenever it gets grayed out, that means that it's gone off screen and it's been shut down. And then whenever I request a new one, it goes and gets an instance that's been shut down. The object pool will also scale. So when my game loads up, I actually create a whole bunch of instances just to get started. But if I needed more at any time, I also request those. So I'll walk through that real quick. In the object pool, I'll start with this. Basically, I have a class here called recycle object. And all the recycle object does is it handles two states. We're either restarting or we're shutting down. And just at its base level, what we wind up doing is we just tell the game object that its active state is set to true or set to false, right? Now, the thing is that this isn't built into any of my classes, right? And if you're familiar with, just the basics of object-oriented programming and having to deal with inheritance, it's very hard to inject this now into the base class of mono behavior. So what I wind up doing is I wrote a utility wherever I instantiate my game objects. So instead of using the default game instantiation, I use my own game object utility to instantiate everything in my game. And in this case, it goes through and it looks to see if there's a recycled script on it. And if there's a recycled script on it, it automatically will build the object pool if the object pool doesn't exist. And it knows how to handle this. I also have my own destroy. So now I'm using my own utility that's smart enough to say, hey, if you're going to create this or you're going to destroy it, it's part of an object pool. Use the object pool. Don't do it on the fly. Because if you're creating lots and lots of objects on the fly, you're creating a lot of overhead, especially if those things need to build themselves up. And then in any class, I can either just simply throw on a recycle. I can throw on a recycled script. So when I'm doing sounds, for example, where you need to make a sound and you need to have the sound actually be a game object and attach the sound object to that game object, you don't want to have to recreate sounds all the time, right? But you don't need to write your own class for a sound. So in this case, what I'll do is I'll just simply say, hey, this sound is recyclable. And then when it comes back active, I'll have something that'll go back and trigger it and tell it to replay the sound. And this is just so I can get references easily. And the object pool is just standard stuff. There's not much to go into for object pool per se, but it's just whenever you are using an object pool, you simply say, hey, get me the next instance in the pool, and it returns you anything that's not active. Also stuff where it knows how to create new instances, knowing how many total instances are active, right? There are times where in this game goats come out, and goats are the way you get power-ups, but I only want one goat on the screen at a time. So in this case, I can say, hey, goat, give me your object pool, and then how many instances of goats exist. If there's more than one, I won't spawn a new goat. I've always wanted to say that. I had a goat spawner. I was doing it on Twitch for a while, and everyone was cheering me on because I made a goat spawner. And I'm like, this is a dedicated spawner just for goats. And then I refactored it so that it wouldn't be a goat spawner and built it into the regular one. Let's talk about optimizing draw calls, right? So there's a few ways to do this. More so because I'm working on 2D games, but texture atlases are your friend, right? You want to pack up as much artwork as possible into a single texture. This way it sits very nicely in memory. So one way you can do it is you can just simply throw every single sprite and texture you have in Unity and then use Unity Pro to have it package it for you. Or if you're a control freak like me, I'll use a external editor in order to package up. So this is Texture Packer Pro. So I'll basically go through, I have a folder on, in the project that's in resources outside of the project, where Texture Packer will just simply look for any changes in that folder and automatically rebuild an atlas. And they have a plugin where whenever they see the texture has been changed, it recuts it up for you. So either way, the most important part is that if you don't do this and you just have single sprites and single textures everywhere, every time you have a reference to that, you're incurring extra draw calls. So most of the time, my game is hovering at around 10, 15 draw calls at any given time. Other things you can do as tricks is move the camera closer in. Unity is really good at cutting off anything that's drawing outside of the screen, right? So make sure that what you're doing is you don't show a huge screen, right? Don't show a lot of things on the screen at any one time. Simplify lighting effects. So this one is one I unfortunately had to borrow from other platforms. I was really excited when I was doing Unity, and I was like, I'm throwing lights everywhere. But when I was doing HTML5, it was really hard to get like really good lighting effects. And then like I put it on lower powered devices, and all of a sudden it just grinds to a halt. So one of the things I do now is a lot of my lighting effects are simply just PNGs overlaid on top. So this game has like a nice vignette around the edges. So if you actually, I'll switch back over. And if we look at the game scene, you'll see that there's a vignette going on, there's scan lines. All this stuff is just textures laid on top. Eventually what I wound up doing is doing part textures for doing fake lighting, and then the other part is shaders. So if you use shaders correctly, you can actually get some really, really good effects. So this, I'm using a shader here now that's, it's called Old TV Effects or something. I think it was like $5 in the asset store. But what was good is that it's now drawing all the scan lines for me, and the scan lines will work across all the different resolutions. It's also warping the edges so it looks like it's a tube TV. And if you get closer to the edges, there's a little bit of, I could do shake distort. But all these effects, instead of having to do this stuff at runtime, especially if you're doing 3D, try to bake your lighting as much as possible. Remember, if you're building towards Android and mobile devices, you also have to make sure you're using the right shaders and the right lighting effects for mobile. So, and the other thing I just recently been using is Unity just launched Unity 5 officially today, but the new UI components are really good. I've been using them all over the place. In fact, everything from like my splash screen is all laid out using Unity's new component system. So I comp it out maybe in Photoshop, and then I'll just rebuild it all in Unity real quick. And then even simple things like this health bar is just 3 layers. It's a top layer for the border, it's a middle layer for the actual bar itself, and then there's a background layer for just when you see the black, and the text on top of it too. And it takes very little draw calls, but what's important about this, and you can sort of see it here, is that if you're building towards multiple screen resolutions, you can anchor it and tell it where you want it to position. So if you're dealing with all these different resolutions, try to use the new component system, because at least that will help you scale a little bit better towards different resolutions. So we'll start wrapping this up, and we'll talk about how you actually test on Fire devices. So the good news is that if you've ever built an APK, you're done. Like, that's pretty much it. We're Android-based OS, so all you need to do is build for ARM and compile for Android. So other things you can go through and you can optimize each device, and I don't have a chart per se, but this is all on our developer portal. You can go through and each device supports a certain level of OpenGL. Also, you can set the minimum API level. So I had it at 9 for default, but API 17 is what we're at for Fire TV, and then 19 for the Fire devices, for Fire tablets. So then that's it. Once you have this, and in most cases, if you're not using something like in-app purchases, and if you're doing just a premium game, you're able to package it up, put it on a device, and it'll just work right out the box. If you are using in-app purchases and stuff, then we have our own in-app purchase system that's tied into the Amazon App Store. Whenever you want to go and test, all you do is plug in one of our devices to USB, and you can publish it over ADB. You just have to get the drivers. So once you get the drivers and everything installed, it's the same thing you do on, at least on a Windows, it's the same thing you do on for any Android device. Fire TV is a little different. Actually, before I get into Fire TV, the last thing is that on all of our devices, you just simply go in and you set them up as a developer mode. So you go to the devices, you look at where the serial number is, you tap on it 5 times, then it sets it to developer mode. And from developer mode, once you set up ADB, you can now basically sideload all the games that you're working on. If you're deploying to Fire TV, it's a little bit different. You don't plug the Fire TV in directly through USB. We actually use wireless ADB. So it's actually really good because not many people want to put their TV right next to their computer and have all this stuff on their desk. So, and the other good news is that once you get a Fire TV, every Fire TV is a dev kit. So there's no special kit that you need to get to start building. If you bought a retail unit off of Amazon, used Prime, got it in 2 days, you can have it deploy a few minutes after opening it up from the box. And in fact, if you actually order Fire TVs, they pre-configure it for you. So once you get it out of the box, it already has your Amazon profile and you're ready to go. And that's another advantage of our store is that the people who are in our ecosystem are Amazon customers, and there are a lot of Amazon customers. So if you're looking for, getting into a new market and trying to monetize that market, one of the barriers you don't want to have to deal with is people having to set up their credit card information or their profiles and stuff like that. So we do a lot to make it very easy for people to spend money in our ecosystem. In order to do the wireless ADB, all you need is the IP address for the Fire TV, and then you simply just use ADB over Wi-Fi. So you just do ADB connect, and you give it the IP address, and then once it's connected, you just simply list it out, and you'll see it listed out as an IP address, but it's just like having the device actually plugged in to the computer. So where do we go from here? A lot of this stuff is something I've been calling responsive game design. And I've been doing this talk for a while at different conferences. And this sort of came back from my web background. We're sort of familiar with what responsive design is on the web. And really, it's a set of guidelines and ways to help you take something like a website and how do you get a website to scale from desktop to mobile. So most of this revolves around in web compartmentalizing blocks of data. And what we do here is we take A, B, C, D, and E, and we just relay it out, right? And this works really good in web because it uses CSS, and all the stuff is usually a visual tweak going from one device to the other. You reuse all the code and everything else doesn't change. When we talk about games, though, it's a little bit more complicated. So this really is how do we take the best parts of responsive design from the web, and how do we take everything we know from building games for years and years on PCs where this has always been a problem, how you go from multiple resolutions, and how do we apply it to modern-day game development? So I wrote this sort of these tenets. These are the three main important ones for what is responsive design and how you can think through building responsive games. And the idea is the first one, just like how we set it up in the talk here, is the game graphics and UI need to support multiple resolutions. And I use this example. Dave was toting his Amiga stuff. I always loved playing Civilization on DOS. I remember playing Civilization. I really loved it, but I was a Mac guy. And it finally came over to the Mac. And Macs always had a higher resolution than Windows at the time. So when Civilization came over, you saw way more of the map as the resolution was high, but all the UI was incredibly tiny around the edges, right? And we have the same problem. If we're going from Retina displays down to lower resolution displays, we want to make sure that it's always a consistent UI across that. Game mechanics. How do we take simple game input mechanics and make them scale across different devices, right? It is possible to go from desktop to mobile to touch and also to controller and back again, right? So there's things I was sort of talking about where in Unity what I do is I abstract the input and I just simply look for the type of buttons, but then I have managers that take that input and boil it down so the game doesn't have to know anything about the type of input coming in. And then the most important part is being able to publish your game to multiple platforms but reuse the same code base. And I think that's one of the things that's brought me over to Unity. I was doing a lot of stuff with HTML5 as well. I really try to stay in platforms that are cross-platform because it used to be back in the day if you wrote a game for one console, you had to port the whole thing over to another console. And now, as indie developers, it's next to impossible to support every platform if you're going to port it, right? Or you had a really good hit and you can pay other people to port it and not deal with it. But the reality is that you need to be able to build one game that works on all these devices. So Unity is a really good one. We support a whole bunch of different game frameworks as well. We also support GameMaker. We support Unreal, I know, works to some extent, so we're also working on getting better support for Unreal, and making sure that you're always reusing your code, right? Get as much code out as possible from your game. So if you want to learn a little bit more about responsive game design and some of my thoughts around it, you can check out our developer portal. I have a bit.ly up there. I mean, one of the best examples of this is a game called Terraria. Is anyone familiar with Terraria? Right? So it's like a side-scrolling kind of 2D crafting game. And I don't have all the slides in this talk here, but what's great about this game, and it runs on all of our devices, is that it actually scales incredibly well. So if you're using touchscreen, I'm just because I'm wired for as a Nintendo child, like I have to have a physical controller. I have a really tough time playing virtual controls on a touchscreen. It just doesn't work. Whereas my son, who's 5.5, he is almost done with Sonic the Hedgehog on his tablet, and it's like torture to me. But I'm like, he's like, Dad, help me beat this level. Like, I can't process this. Let me hook up a controller. But that being said, Terraria is really cool because you can play it on a touchscreen and you can do light things. Like you can go around and you can explore the world. You can collect things. You can sort of build too and use it on touch. But then if you want to do something more complicated like fight a boss or go and really dive deep and start doing more of the combat or the mission stuff, you can switch it over to Fire TV or to another device that has a game controller and start playing it on the game controller. And one of the things that they do really well, which is another tenet that I sort of took out for now, but they're able to save their game data and sync it across all the devices. And I think that's also another interesting aspect to where responsive game design is going to be going, is being able to, when you buy a game, have it available on all the devices. So if you buy a game in our App Store, you can have it available on every device that you own that runs the App Store, and then you can play it how you want. The last thing I'll sort of leave you with is just, the old World War II, like, we want you, like, we want your games. Like, it's, we want developers to be successful, and being in other app stores and offering up your game to a whole new audience is one way to help make you guys more successful. And we're here to also help you be successful. So I wrote a little post that just kind of walks through kind of why to pick the Amazon platform, what's important about it. I think some of the stuff you're going to start seeing for the rest of the day is going to help solidify that, especially the stuff around Twitch and just what that means for game developers. Like I was saying earlier in the talk, like I'm really excited about just, one, building my games and broadcasting it on Twitch, and also how do you get people involved in making your game. So all this is now becoming under one sort of strategy that we have, and that'll be explained throughout the rest of the day. So I'm going to end, I think I'm 3 minutes early. And that being said, please, everyone, if you can, I don't work on tips, but we do work on surveys. So it'd be great if you guys can fill out the survey and just let us know. It helps us the most. Just let us know what you thought of the talk. There are going to be surveys throughout the day, and we're actually raffling off. Are you noosing me off?
No.
Okay.
Announcement about the survey.
Announcement?
What we're going to do is we're going to raffle off 4 devices at noon. So you do not have to wait till the end of the day. We're going to do 2 Fire Sticks, 2 Fire TVs, and a Fire Phone. So if you fill out that survey right now, what you do is you go outside and you're going to get a raffle ticket. And then after Peter's session, I'm going to take the raffle tickets and we're going to give out some devices.
See, and all those people left in the morning and they missed out that news because free devices are coming sooner than expected. And that being said, the other thing is that we do a lot of developer events. So we're all over the world. And if you want to learn more about our events, we have a dedicated event page. We also have a dedicated developer portal. It's free to be a developer on our platform. So, and what I always tell developers is that I want to be a checkbox for you guys. I don't want this to be a very difficult process, and I take pride in the fact that I work with developers to make sure that if you're building for Android, that you can support our platform. And if there are things that are trouble for you, that if you need help with, if you run into walls or things that keep you off of our platform, that's what my email is for. And that's where you let me know, and I'll put you in touch with either I'll try to help you or we'll put you in touch with the right people, because we want to make sure that you're successful on our platform and other platforms as well. So thank you, and stay tuned for Peter coming up and talking next.
Just unplug your power.